So hi guys, in today's video we are going to look at the applications of dimensional analysis. Okay, there are basically three main applications of dimensional analysis. First one is to verify the correctness of a given equation. To verify the correctness of a given equation. So what do I mean by this is, for example, we take a formula. So t is equal to 2 pi root of L by G. Okay, why do we say that this is the right way of writing this formula? Why can't this be t is equal to 2 pi root of G by L, or t is equal to 2 pi root of G cube by L power 5? Why are these things wrong, whereas this alone is specifically right? So that is what we will be able to find using dimensional analysis. So basically, what do I mean from this is, the dimension in the LHS should be equal to the dimension in the RHS. Okay. Before that, let me give you an introduction on what are these physical quantities. So this is time period. This is length. This is acceleration due to gravity. Okay. So now LHS is time period. So I have a dimension t. I don't consider constants for my dimension analysis, so I can just don't consider this. And then I have length. Small l is length, so I can put L in the numerator, and in the denominator it is acceleration due to gravity, so I can write LT minus 2. If you're not able to understand why am I writing it in this way, you can go refer to my previous video where I explained how to derive the dimensional formulas for more than 40 plus equations. So you can go have a look at that video. That will give you a better understanding on how to do this. So L would get cancelled, and then if I bring this t power minus 2 to the numerator, it will become t square. So it is root of t square, which is equal to t. So from this I know that LHS dimension is equal to RHS dimension. Okay. In case if you want me to give a second example, I can maybe give you a second example where I consider another equation, which is escape velocity is equal to root of 2gm by r, for example. So you will be learning about escape velocity in your gravitational chapter in class 11th. So it is fine if you don't understand where do you derive from this or what is this. Just consider only the physical quantities that is getting involved. So this is escape velocity. So g is universal gravitational constant. I've also derived the dimension of g, capital G, in my previous video. Please do have a look at that. Universal gravitational constant. M is mass, R is radius. Okay. So now the LHS should be basically equal to RHS. Okay. So in the LHS I have velocity, which is LT minus 1. So what should I have in my RHS? That should also be LT minus 1. So I don't consider constant, so I can remove this. So this will be basically, before that let me just give you what is the dimension of G. So G is M inverse L cube T inverse 2. I have derived this in detail in my previous video. Please do have a look at that. So I can write what is G here, M inverse L cube T inverse 2, and then I have mass, and then I have radius, which is the measurement of length, so I'll put L, and I will take a whole root over here. So M will get cancelled, L and the cube will become square. So now I have root of L square T power minus 2, that will give me LT power minus 1. So from this I know that LHS is equal to RHS. Okay. So we have dimensionally proved that this equation is dimensionally correct. So So now let us move on with our second application of dimensional analysis, which is to derive the relations between physical quantities. In a simpler term, you can just keep it like to derive the formulas. Okay, so for an example question, let me just say mass is expressed or related to force, which I am representing as F, length small l, and time small t. Okay, so now then I can maybe ask how to express mass in terms of the other three physical quantities. So this is the question. Just understand the question. Take a second to read this question and understand the question. And I'll let you know what do I mean from this question. So I took this formula. Time period is equal to 2 pi root of L by G. In this, time period is expressed in terms of length and acceleration due to gravity. And it is expressed in a specific way. So time period is expressed as 2 pi root of L by G. So it is basically time period is equal to 2 pi L to the power 1 by 2 by G to the power minus 1 by 2. So why is it getting expressed in this way? Why can't it be 2 pi L to the power 5 and G to the power 6 is what we saw previously using our verification of the given formula. But we'll see how to derive this relation in our second application. So here they are asking you to express mass in terms of force, length, and time. Okay, so that could be something like Ft by L or Fl by T. It could be L square by T power 4, or it could be Lt by F. It could be root of F by Lt. So it could be any of these, but all these are not right. There is one relation that is exactly perfect, and that is what we will be deriving, and we will be seeing how to derive. So we have mass. So basically what are we trying to do is to look at the powers of these physical quantities. So here F is 1, T is 1, and L is basically minus 1. It will be going to the denominator. Okay. So we are basically trying to figure out the powers of these physical quantities in respect to mass. So now I can write mass is directly proportional to F power A, L power B, T power C. So I need to know, I don't know what are these A, B and C. If all the three are 1, it will be M is equal to F, L, T. If C is minus 1, it will be M is equal to F, L by T. So that is what we are going to figure out right now using dimensional analysis. Okay. So now in order to remove this proportional symbol, I can just add a proportionality constant, which is K. So then I will have F power A, L power B, T power C. I don't consider it constants for the purpose of dimensional analysis, so I can remove this. So in the left hand side, you have mass, on the right hand side, you have these quantities. So mass, the dimension can be basic. In the left hand side, the dimension can be basically represented as M power 1, L power 0, and T power 0. Okay, since L power 0 and T power 0 is 1, which is equal to, I'll write force dimension. Since it is F power A, I'll write MLT power minus 2 whole power A. This is length. Small l is length, so I'll write L power B, and small t is time, so T power C. Okay, I have this right now. So now I'll group the similar quantities. So this is M power A, L power A plus B, T power minus 2A plus C. Okay, I have this. So this side I have m power 1, l power 0, t power 0. So now basically you need to compare between the LHS and RHS because both the LHS and RHS should be same. So now you know m has a power of 1. So a should be equal to 1. Okay, only then it will satisfy. And then I know L has a power of 0. So a plus b should be 0. A plus b equals 0. So I know b is equal to minus a is 1, therefore b is equal to minus 1. Okay, I've got b is equal to minus 1. And then I have minus 2a plus c equals 0. So c is equal to 2a. Okay, so a is 1. Therefore, I will be getting c is equal to 2. C equals 2. So this is what you need. After this, I can go to my first step where I've written m is directly proportional to f power a, l power b, t power c. Now let me just substitute a, b and c over here. So m is directly proportional to f power 1, l power minus 1, c power 2, c square. So now m is directly proportional to f. So this is t, sorry. This is t power 2 f t square by L. In order to remove this proportional symbol, I can just add a proportionality constant. So k f t square by L. So k is the proportionality constant. Okay. So from this, I know that m is directly proportional to f, m is directly proportional to t square, and m is inversely proportional to length. So this is what you can use dimensional analysis for. So you can basically derive the formulas like this. So in an examination, you know what are the quantities, physical quantities that are related to each other, but you forgot how it will be expressed. It is fine. You can just derive those formulas dimensionally and then you can pretty much solve it. Okay. So with this, we come to the end of the second application of dimensional analysis. Now let us move on to our third application, which is to convert one system of units to another. To convert one system of units to another. Okay, just bear with my handwriting. So before moving on with this, let me just give you give an introduction to three different system of units. We have MKS, we have CGS, and then we have FPS. Okay, so MKS is meter, kilogram, so kg, second. CGS is centimeter, gram, second. FPS is foot, pound, second. Okay, so basically you can use any of these system of units. So we mostly use MK system here in our studies, etc. So you can see Newton's unit is kilogram meter per second square. This is how we will be expressing force in its SI unit. So we are mostly using MK system. But there are some people who will be using CJ system of units for their own purposes, and you also have foot, pound, and second. So basically, you can tell your weight in terms of kg. You can tell your weight in terms of gram. You can also tell your weight in terms of pound. It depends on the use case and where do you want to use these different system of units. And you also have these conversion factor. So you know 1 meter is equal to 100 centimeter. You know how to convert these units from one system to another. Okay, so basically this part of the application of dimensional analysis is to basically convert different physical quantities from one system of units to another. So let me just give you an example. Okay, so the example question will be the SI unit of force. This is just an introduction. In MK system is Newton. Okay, this you might be very well aware of. You will be expressing this as N. You will tell 1 Newton of force, 5 Newton of force, 10 Newton of force. This is what you learned usually. Whereas the SI unit of force in CGS system is dyne. Okay, it is dyne. It is known as dyne. So we don't use this because we prioritize MK system in our day-to-day learning. But we don't use this. But this is still there. Dyne is still there. But how do you know 1 Newton is equal to how many dynes? So this is what dimension analysis is helpful for. So you can find this x basically. Okay, let me just tell you how to do. So I can just write x is equal to 1 Newton by dyne. So Newton is in a particular system of units where there is a specific mass which is m1, specific length which is l1, and specific time which is t1. Okay, and dyne is in a different system of units. Therefore, I am taking the mass to be m2, length to be l2, and t to be t2. Okay, because they are different. The units of both these things are different. Now I know. So Newton is force. Newton is the unit of force. So I can write the dimension of force in the numerator, and dyne is also force. I can also write the dimension of force in the denominator. So x is equal to m1 l1 t1 power minus 2, which is the dimension of force in the first system. And then I have in the dyne system you have m2 l2 t2 power minus 2. Okay, so now I can group these quantities. So I can write it as m1 by m2 L1 by L2 T1 by T2 whole power minus 2. And now Newton belongs to the MKS system. That is what I have told you. Dyne belongs to the CGS system. Now write those units in the place of M1 and M2, L1, L2 and T1, T2. Okay, since M1 is mass in the first system, that is kg, whereas in CGS system it is gram. In so L1 is in MK system, so it is meter by centimeter. Okay, then the time is same for all the three, so it will be second over minus 2. So this will be x. Now we need to bring these units to the same type of units. Okay, so I know 1000 gram is equal to 1 kg and 100 centimeter equals 1 meter. So in terms of, so instead of kg I can put it as 1000 gram, and instead of meter I can put it as 100 centimeter. Okay, I'm just bringing the units in the same way. So I'll just put 1000 kg, sorry, 1000 gram by gram into 100 centimeter by centimeter into second by second whole power minus 2. Okay, so gram will get cancelled, centimeter will get cancelled, second will get cancelled. So now what do I have? X is equal to 1,000,000, which is basically 10 to the power 5. So now I know 1 Newton of force is equal to 10 to the power 5 dyne. So this is how you convert one system of units to the another and find the conversion factor using dimension analysis. So as a homework in this section, you can maybe take so 1 joule. So joule is the unit of energy. Okay, so in my previous video I've derived the dimensional formula for energy. You can go have a look at it so that you can understand how to do that. Is equal to how many erg. So joule is the SI unit of energy in terms of MKS system, and erg is the SI unit in terms of CGS system. So you can go and have a look at how to derive the dimensional formula for energy, and then find the conversion factor for this. Okay, so you can take this as homework and maybe figure it out. It is very simple. In the same way, you will just do it in the same way as we have done before. So in case if you have taken notes, you can just follow the same steps. So the only thing that will change is this part over here. So instead of force dimension formula, you'll be putting energy dimension formula. That is the only change that you'll be doing. And then it is almost same. Okay. So in this video, we have looked in detail at the 3 applications of dimension analysis. I hope this was helpful and you were able to understand this video. If that is the case, make sure you like this video and also subscribe to my channel. So thank you. Have a nice day.